Okay, the first one looks something like this. There's a bridge. Mass is equal to, we'll say, 10 kilograms. And on that bridge, we have a person here. And the person mass is equal to 15 kilograms. Pretty small. And as you know, on a bridge, there will be supports. So this is support number 1 and support number 2, okay? And here's support. I won't call it number 2, I'll call it support B. So we've got support A, support B. And this mass right here of that person. Okay, so the question is, what are the forces on support A and support B? The supports could be anything, but in most bridges, there are probably some column. If you look at the overpass that they just put in Pitt Meadows a couple of years ago with that shopping center, the supports are always columns sticking up. They're made of concrete, reinforced concrete, and they've got steel in the middle and all that kind of stuff. Okay. These ones, who knows? It might just be a piece of wood, or it could be a chunk of concrete too. But what force does that support have to hold up this person and the bridge? That's the question. So just like before, we have to consider all of the forces acting on the bridge, but in this situation, it's not going to be as simple as just sum of the forces equals 0, and here is why. So draw a free body diagram first. So I'm just going to simplify this drawing right here with a drawing of all the forces on the bridge. Okay? So here's the bridge. And by the way, the bridge, I need to give it distance to it. So I'll say that it's 4.0 meters. And I'll say that this person right here is at 1.25 meters. So 4.0 meters, 1.25 meters. And I want to draw all the forces acting on that bridge. So I've got a person standing here, and their mass is 15 kilograms. They have a weight due to that mass, and that's the weight of the person, okay? The bridge has a weight too. And where, do you guys know where the weight of the bridge is? If it's on the uniform sides.
The middle?
Yeah, right in the middle of the bridge. So that's where we put the weight of the bridge. So it's where the center of mass of the bridge is. So it's just like the meter stick lab that you guys did. You brought your fingers in and found out really where is the middle of the bridge? Where should you concentrate the weight? It's generally in the middle of the bridge. So here's the weight of the bridge. And then there's two other forces. There's the support here, force at B, and the other force here at A. So there are four forces acting on here, on the bridge. And I want to find force A and force B. So this is simple. It's an up-down problem. It doesn't even have different directions to it. There's no left or right or anything. I could say sum of forces equals 0. So the sum of the force vectors equals 0. So FA plus FB plus weight B plus weight P equals 0. This one's a positive force, that's a positive force. That's a negative, that's a negative. But I can't get anything from this because I don't know this one. It's unknown. This one's unknown. That one's known. That one's known. So I've got one equation, two unknowns. This is not going to work. So one equation with two unknowns. So I would need to have some other equation to help me find out what FA and FB are. Another way of writing this, by the way, is if you've got all up forces and down forces, you could say, instead of sum of the forces equals 0, you could say F up equals F down, but it turns out to be the same thing, right? So if I only have upward forces and downward forces, instead of saying sum of the forces equals 0, it might be more convenient to say F up equals F down. As I drew it, FA is upward, FB is upward, and the two downward forces are weight B and weight P. And it's still one equation, two unknowns. It's just restating this one. That's unknown and that's unknown, and that's the issue. So again, whether you write it sum of forces equals 0 or F up equals F down, which says the same thing, it's not going to get you. So you have to go to torques. So this didn't work for us. We have to try torques. You should avoid the torques as much as you can because it gets a little bit more complex. But if this doesn't work for you, the sum of the forces equals 0, you have to go to torques. Okay? So torques say sum of torques equals 0. And what we said, really what that means is torque clockwise equals torque counterclockwise. So we've got that bridge right here looking like this, and I've got an upward support here, an upward support right here. So one upward support here, one upward support here, one weight down here, and one weight down here. If I could just hold it right here and say I'm going to call this one my pivot point, and what forces are involved, I would have that weight here times that distance, and that would make a clockwise torque. I would have the weight of the person here times that distance, and that would make a clockwise torque. I would have this weight too, but it's no distance from the pivot point. The pivot point is right here. So even though this force exists right here, it's got 0 distance, and torque is force times distance. So force at A times 0 would be 0. This one over here though, force at B times the full length of the bridge makes a counterclockwise torque. So all of a sudden I've got no torque, one torque, another torque that we know, and then one that we don't know. We'll have one equation with one unknown. So this is the way you could actually solve this one. If I put these, I'm going to put the distances in right now. This distance right here is half of 2, so 2 meters. This distance right here is 4 minus 1.25, which is, yeah, 2.75 meters. And then this distance right here, obviously, is the full 4 meters. So if I choose the pivot point at A, at this support, then I can find out what this force is. So you can move the pivot point or put the pivot point wherever you want it to be, but I'm going to choose the pivot point to be right here at point A. And if I do, and I use this torque equation, I will have one equation, one unknown. And here's what it looks like. At this pivot point right here, I'll go torque clockwise equals torque counterclockwise. I don't know whether FA is making a clockwise torque or a counterclockwise torque, and it doesn't really matter because there's no distance. So I could say FA, the force at A times 0 meters, it just doesn't contribute at all, plus the weight at B times that distance, which is 2 meters, plus another clockwise torque is the weight of the person times 2.75 meters is equal to the counterclockwise torque, which is the force at B times the full length, 4.00 meters. So go weight of the bridge times 2, weight of the person times 2.75, and weight of the support at B times 4 meters. This one is 0. This one, I know what the weight at B is. The weight of the bridge, I should say. The weight of the bridge is 10 times 9.8. And then times the 2. The weight of the person is 15 times 9.8 times the 2.75. And that equals the force at support B times 4. And I've got one equation, one unknown. That's a known number, unknown. So I can find out what FB is. The force at support B. So can you guys just crank through, chug it out, and let me know what the force at B is? Anyone got it? 150? Anybody else too? 150 on the house there. Nice. Okay, anybody else? 150? 150?
Yeah.
Okay, great. Thanks. So 150 is the force at support B. So that's the upward supporting force at B. And now the easiest way to do it, to find the other support, is just say the upward forces equal the downward forces. So you can go right back to this equation. Instead of torques, which will give you the same answer, go back to the easier one, F up equals F down. If you don't know what I'm saying, don't worry. I'm just going to use the torque equation to find the force at A as well. So use torque equation to find the force at support A. And to find the force at support A, you need to choose your pivot at point B. Choose pivot at point B. If I choose the pivot at point B and go torque clockwise equals torque counterclockwise, I will get one equation and one unknown. So look at the diagram using B as the pivot point. So this point right here, I'm going to draw a free body diagram with the forces on, with the distances relating to that point right here. So I've got a bridge here, and I've got a support here. FB. I've got this support right here, FA. I've got the weight of the bridge here, and then I got the weight of the person right here. But the distances are related to point P now. So the person is 0.75 from here, or 1.25 I should say. So that distance right here is 1.25. This distance right here is 2.00 meters. And then this distance right here is 4 meters. So if I use this as the pivot point right here, then I would go torque clockwise equals torque counterclockwise, and it would look like this. Think about it. I'm right here. What would cause this meter stick or this bridge to go in a clockwise direction? So I've got that bridge right here, and if I have a pivot point right here now, that one's going to cause this bridge to go clockwise. These guys, the weight of the bridge is going to make it go counterclockwise, and the weight of the person is going to make it go counterclockwise. So I've got 2 counterclockwise torques and 1 clockwise torque. In fact, the force of support A times 4 meters is the only clockwise torque, and it equals the weight of the B, weight of the bridge, times 2 meters, plus the weight of the person, times 1.25 meters, plus, if you want, the force at B times 0 meters. It's right at the pivot point. That's how this one becomes 0, and that's how you end up getting one equation with one unknown. So weight of the bridge, we know. I'll just put in the numbers like we had before. It's 10 times 9.8, and then times 2. The weight of the person was 15 times 9.8, and then times 1.25. This term is 0. And that equals the force at support A times 4. So again, one equation, one unknown. What does force at A turn out to be?
94.94.
Yeah, 94.94.
Yeah.
Anybody else? So 94.9 newtons.
Could I just put in the above equation?
Pardon me?
Yeah, just put in the equation up above.
Yeah. Nice. If you didn't want to go through all of this baloney here to do another torque equation, you could have done what Nick just said. You could have said, hey, couldn't I have just done force up equals force down once I found the force at B? Because if that's the case, force at A plus force at B is equal to the 2 downward forces, weight of the bridge plus weight of the person. And look at the first force that you guys got. It was 150. This one right here, when you did the torque equation, you got that to be 150. This one here is, of course, 10 times 9.8. And this one's 15 times 9.8. And now you've got one equation, one unknown. So this is definitely the quicker way to go instead of doing a whole different torque equation. Once you've found one of the supports, that's definitely easier to do it this way. So this has to give you the same answer though. If this doesn't turn out to be 94.9, okay. So 95, rounding up. This one rounded up is 95 too. Okay, everyone okay with that? So when you do this and subtract 150 from it, no surprise, it's 94.9 or 90.5. Just like this one. Okay, these two have to be the same. So if you've got extra time on your plate, you could always do the check and see if it really did turn out to be the same answer, but it's redundant, not necessary. Everyone okay with this? It's a mouthful for sure.